My name is Ben Badio. I work for TravelTab, as you can see here. TravelTab is a company based in Winter Park. We offer these devices here to rental car agencies, and then they rent these devices to people renting cars, and it provides GPS, phone calls, Wi-Fi hotspot, etc. What's up?
That's not a mobile phone?
This is a mobile phone.
Okay.
But for the customer, it is a way for them to not have to use their own mobile phone to do a lot of that cool stuff.
Like a live
So,
phone, right?
so it's like it's like a Garmin basically, but better because it does a lot more. So that's what we do, and me and Nigel are Android engineers for the company. These are Android devices, and so we build the applications for them. At TravelTab, we use this architecture that we're both big fans of called Flux, and that is what this presentation is about. So, Flux the World, welcome. So first we're going to start by talking about what you need to know if you want to take advantage of this architecture. And the answer to that is actually very little. Basically you just need to have some basic experience with Android, some familiarity with the platform. You will also need to have some experience with dependency injection, specifically with Dagger. Now, you can use the architecture without doing dependency injection, but if you want to have truly clean code, truly clean architecture, dependency injection is the way to go. So Dagger is highly recommended. An understanding of the pub-sub pattern, the publisher-subscriber pattern, basically just emitting events and then having things listen for those events. A basic understanding of that pattern. You can search this in Google and look it up, and chances are, if you don't know what it is, you've actually used it before and you just weren't aware of the name of it. And then lastly, some experience with RxJava is recommended, but it's not actually required to get started using Flux. It's just highly encouraged. So,
what is RxJava? My fault. I'm not a developer, guys. Sorry.
RxJava is it's a library that allows for reactive programming in Java. It's a lot to get into though, so I'm going to go ahead and keep moving with the presentation. I would recommend looking it up though. So first of all, let's talk about MVP, Model View Presenter. Model View Presenter is not the MVP. It's not the most valuable pattern. This is how I feel about it anyway. I personally, when trying to use MVP early on in my development career, got frustrated very easily and very often. There are some problems with it, and some may not agree with me, but I tend to feel that it is unnecessarily complicated. If you use MVP in your daily development life, you can pat yourself on the back. Because you are doing something that is pretty complicated. It's probably easier once you get used to doing it, but when you look at this chart right here, if you're someone who's just getting into Android development, or any development for that matter, it doesn't really make a lot of sense at first glance. It's also inconsistently implemented. It can get really messy once you start having to build multiple presenters for multiple views, and then the interfaces for those presenters, multiple models, so on and so forth. You end up with a supposedly clean pattern becoming not so clean. And the same goes for MVC and MVVM. These patterns claim to be clean, but in practice they don't end up being. And so this is the type of thing that we tried to get away from, and we kind of stumbled upon Flux as a pattern and went with it, and we've been very satisfied. So enough about MVP. Let's go ahead and talk about, actually one more thing. You the real MVP. I just wanted to make that clear.
Nice.
So, why Flux? Flux basically solves all the things I just described about those other architectures. Flux is unidirectional. Unidirectional means everything flows in a single direction. All of your data goes one way. You never have to worry about having to call back to something that you just called to. So in model view presenter, the presenter has to the presenter and the view have to communicate back and forth between each other. But then if I remember correctly, the model doesn't have to do that. So you have arrows that sometimes point in both directions and some that don't. Confusing. One flow, one line, you'll see in our diagrams as I go on, it's extremely simple. It's a truly clean architecture. Uncle Bob, the guy who first came up with this idea of clean architecture, would be very happy if he used Flux. He's going to pat you on the back. And lastly, it is a simple mental model, and that really goes back to this first one. By having it be unidirectional in one single flow, it makes it very easy to understand how that model works in your head, and you don't have to kind of sit and think, wait, is this supposed to be connected to this in this way? Am I doing this correctly? Chances are, once you get used to the pattern and you're familiar with it, it'll be really easy for you to do it correctly every time you want to try it. So, this is the Flux Flow. Like I said, it's one direction. You can look at these arrows and you can notice that they all point the same way. So, we have here actions, the dispatcher, the store, and view. And really, the primary components of Flux are these three right here, the actions, the store, and the view. And I'm going to talk more about these, but this is generally the flow. The way that Flux works is if we have something that needs to happen in the application, let's say a user presses a button, and that button is supposed to do something. So that button is supposed to perform an action. So when the user presses that button, the button is the view, and when they press that button, the view requests an action. That action gets passed to the dispatcher, which communicates that action to the store. Once it gets to the store sees that action and then does whatever logic is necessary. Once it's completed that necessary logic, it will emit a message out to all views that are listening for messages from stores. And then those views can react to that action. And then the pattern just happens over again. So if a user hits a button, the action gets created, the dispatcher passes it to the store processes the action, passes out a message, the view receives the message and then reacts. And that's basically the pattern. It's really that simple. We're going to get into the details about what each of these things do and talk a little bit more about how they work, and you'll see some code examples. And then Nigel is going to present a library that he created that further simplifies this when it comes to implementation. So, stores are the first thing I want to talk about. They are really one of the crucial components of Flux, and they are the component that most people at first are confused by, and so I wanted to cover that one first. So stores hold the data of the application. They're responsible for keeping track of your application state. Essentially, a store is where you do all of your data handling. A store is where you do all of your business logic. All of that happens within stores, and that way you're not doing this work inside of your views or in other places. Stores must be registered to the dispatcher, and we'll talk about the dispatcher in a second. But basically, stores receive actions, and once they receive actions, they perform work based on those actions. Data in a store can only be mutated by responding to an action. So what that means is that if you are using this pattern correctly, there should be no way that you can make any changes to any of your models, any of your data, without contacting a store in some way. And the way that you contact a store is through actions. And so that said, there are no setters in stores. You can have getters. if you have static data that you want to be able to grab, you can have getters in your stores, and you can call those getters from your views. But there are no setters. You should not be able to set your data, your state, from any other place but within the store itself. Every time a store changes, every time it processes an action, it does something, what it needs to do at that point is it needs to emit a reaction. Essentially, it notifies the views that are listening that there is a change that's occurred. And then once those views hear that, they can act accordingly. They can do something based on that change. And there's a useful analogy that I'm going to be using throughout this presentation here, and it's fast food, because I love fast food, and it also helps understand the mental model. So in this analogy, a store is like a fast food restaurant. If you think about a fast food restaurant, they are responsible for tracking their inventory. They're responsible for the creation of their product. So that's cooking the food, storing the food. All of the things that happen related to the restaurant happen in the restaurant itself, right? So what stores do. So this is just kind of a walkthrough of, it's like a step-by-step of what happens in a store. So a store will receive an action. The dispatcher is going to hand it over. Once it receives that action, it determines whether or not it needs to do any work. So you can have multiple stores, and you can relate those stores based on what your application is doing. So for example, you may have a store for login, and you may have another store, you may have another store that's responsible for a caching service, something that's saving data. When a store receives an action, it first checks that action's type, and it determines whether or not this store is something that's going to handle that action. If it decides that it is going to handle that action, it goes ahead and performs the necessary logic. Once it performs that logic and it completes, it will emit a reaction. And then again, the view receives that action and then acts accordingly. So that's all a store really does. And here's an example of a store. So I'm sorry if this is a little blurry, but basically up here we have in our, this is actually just a constructor, but inside of this constructor here, we're registering this action subscriber here. Nigel's going to discuss more about the setup of his library, but this is his Flux library, Flux Ion, that we're using. Really, I want to focus on these two right here. So these two are examples of store methods that handle actions. If the start quiz action got passed into the store by the dispatcher, this is the method that would run. And then once it runs this method, the final thing it does is it will emit this reaction. A reaction is simply an object that gets passed that can contain, a type and some data. And then once the views receive this action, they can act on it. The same thing happens here. You can see that this action type is get next problem. So when the store receives an action with the type get next problem, it will do this work. And then once it's done that work, it's going to emit a reaction. And you can see there that it will pass some data along with it. And again, that goes out to the view, and then the view can handle it from there. So, I've been talking about actions a lot. That's really the next thing that we should discuss. So an actions they represent the internal API of your application. They are essentially the objects that get passed around in order for this whole thing to work, basically. So an action is a simple object with a type and some data. And the data is not actually required. The main requirement is that each object or each action has a type, so that when the stores receive that action, they can read the type and decide whether or not they need to do work on them. All actions have a type. An action type should describe the action taking place. So if the action is to allow a user to log in, then a good name for that action would be, or that action's type would be attempt login, right? You can pass data with an action so that the store has what it needs in order to perform the business logic it needs to do. And so, you know, if you do that, you organize them in key value pairs. In the code example you'll see on the next screen, we'll get a sense of what I mean by that. Not all actions need to contain data, I mentioned that. And then the analogy here, continuing with the fast food restaurant analogy, actions are like fast food orders. So when you place an order, you say, I want a burger with no tomato and fries extra salty. You know, that order gets, the cashier accepts that order. And then that order gets processed by the restaurant, so it gets created for you, and then it gets passed back to you. So if you're the customer, the view, you request that order, which is creating an action, and then once the store completes that order, you get your food. Simple as that. Actions creators. So an actions creator is essentially a class that you can create to organize your actions. And this is great because when you use an action creator, you can inject or instantiate this object, this action creator, into any place where you want to perform actions. And then when you want to perform an action, you just make a call to that object and choose the action method that you want to call. Again, you'll see an example in a moment here. But it's a simple class where we can organize our actions. Each action has a corresponding creator method. And that method is responsible for building the action object and then passing it on to the dispatcher that then passes it to the store. Performing an action is as simple as injecting or instantiating the action creator in the class, the view that you want to perform the action in. And then you call the actions method, and then you high five yourself and your friends. It's really that simple.
Yeah, high five me.
So this is an example of an actions creator. And this one's very simple. We have two actions in here. This first one here is get next problem. And we saw in our store the response to that, the type was the get next problem type, right? So what we have here is when this method gets called, it's going to go ahead and emit this action. And when it emits an action, that's what sends it onto the dispatcher and into the store. And so we have here the action type, get next problem. And in this situation, we want to provide some values with it. And so in this situation, we are providing this answer value, which is a string, and we give it a key answer. So that inside of the store, when we're processing this work, our business logic can grab that action and then get the object that is under the key answer and then use that information. And then this one is an example that doesn't have data because data is not required, but what is required is a type so that the stores know what the order is, right? And so here we have simply start quiz, and then we emit an action with the type name start quiz. So anytime we want to perform one of these actions, we just inject or instantiate an action creator, and then we go ahead and if we want to get next problem, we say action creator.get next problem, and there you go. The dispatcher. Now this one I'm just going to go over briefly. Nigel's, the nice thing about the dispatcher is that you only need one. You basically never have to create it again after you created it the first time. And then if you use Nigel's library, the library actually creates this for you, so you never even have to worry about it. It further simplifies an already very simple architecture. But the dispatcher is essentially responsible for passing the actions from the actions creator to the store. That's all it really does. It's simple as that. There's only one of them. In typical Flux Flow patterns, it will pass the action to all stores, and then each store uses like a switch case or something like that to check and see whether or not it should respond to that action. But again, Nigel has further simplified that, so he'll tell you about that in his project. The dispatcher performs as you see here. Basically, when the user interacts with the view, it's going to respond to that interaction by calling the action creator method. Once that method gets called, we already discussed this, the action is passed to the dispatcher, and then the dispatcher just passes it to the store. Simple as that. It's a handover. The analogy here is that the dispatcher is like a cashier. It's the person taking your order. So if you are the view, if you're the customer and you place an order, which is an action, your dispatcher is your cashier, and they're going to be responsible for taking that action, passing it to the guy in the back who's going to make the food for you, and then getting that food back to you. Views. So we already know the analogy here. A view is like a customer. A view is the person who is ordering the food, right? So data from stores are displayed in views, displayed in air quotes, because views don't have to be visible, right? Views request actions by calling the action creator methods, and we discussed that. Views subscribe to stores, and then they listen to change events from those stores. This is where that pub sub pattern comes in. Basically what this means is when we set up a view, we set it up such that it is it's listening for those changes, those reactions that come out of the store, and whenever one of those reactions are received, it can perform based on what it receives. So when a store emits a reaction, all the subscribed views that receive that action can react accordingly. Not every view has to react to every emission, right? But if you have a login view where you put in a password in a username and then you hit a button, you would probably want that view to respond once the attempt login action has been completed, right? So that'd be an example. Typical views in Android can be really any component, an activity, a fragment, a service. These are all views. I wanted to point out that a service can be a view because when we say view, we think visual, but views don't have to be visible. They just have to be something that can request actions and something that can listen for changes, listen to the store for reactions. And I already mentioned that a view is like a customer, the person who's placing the order and the person who ultimately receives that completed order, right? So this is an example of a view. It's a main activity. And what we have in here is in our onCreate, we're just setting up the activity, but the main line I want to point out here is right here, this one where our little light bulb is. This action creator.start quiz. So this is the view calling the action, and this starts the flow, right? The action gets called. The store performs that action. Once the store is finished processing that action, it emits a reaction. It emits a change, right? And so you can see here we have these React methods. Now again, this is Nigel's library in action. It makes this very clean. Basically, if you want to subscribe to a reaction, you can just set up a method like you see here. So this one here, when we do start quiz, the thing that we're expecting when we start the quiz is for the first problem to be shown. So we have here, we're going to react on this type, show first problem. And when the view receives that response or receives that reaction, we're going to do this method. We also here, we have show next problem. So when the view gets this one, it subscribes to this, and when this shows up, it goes ahead and does this. Another view might also be subscribed to the same store, but does not have to have these related methods, because not every view has to respond to every event, right? So putting it all together, I've been mentioning all this a lot, but now we can kind of all see it as a single pattern here. So we're just going to start from the top. Let's say you're a user and you are pressing a button. The user interacts with the view first. Once the user interacts with that view, the view at that point will request an action by making a method call on the action creator. The action creator, once it receives that call, it creates the action, and then it passes that action to the dispatcher. The dispatcher then sends it to the store. So that's that cashier telling the guy in the back that he needs to make that burger and salty fries, right? Once the store has completed the work done, or the work necessary for that action, it emits a reaction. It notifies the views that there has been a change to the application state, right? And so once that happens, the view, listening for those reactions, they perform, whatever work needs to be performed based on those emissions. And as simple as that. And you can see the pattern here. And again, remember, it's one direction. Everything goes in one direction. View makes an interaction. The interaction calls the actions creator method. Actions creator creates an action. The action gets sent to the dispatcher. Dispatcher passes it to the store. And the store will emit this event, which is a reaction, and then the view listens for it. Always in the same direction every time. You never have to call back from the view to the store, or you never have to go back in any direction. So, we're Android developers, right? Let's talk about Flux and Android real quick. Things to know about Flux and Android. First, best practices for Flux is that data should go in and out of stores on the main thread. And so that means when the actions creator creates an action and passes it to the dispatcher, that occurs on the main thread. When the dispatcher communicates that action to the store, that's also on the main thread. Once it's in the store and you're performing that business logic, you can perform that logic on whatever thread you please, however works best for efficiency in your application. But when it's all said and done and you want to communicate to the views again, that communication needs to happen on the main thread. So this is something to keep in mind. Now the nice thing here is that if you are familiar with RxJava and you know the basics of it, you can make this process very easy by leveraging the subscribe on and observe on operators. Simply, you can subscribe on whatever thread works best for the process that you're working on, and you just observe on the main thread, and that's it. And then the last thing I wanted to mention here is that views don't actually have to be visible, and I kind of mentioned that earlier. A view is simply, and it's simply something that can make calls and can listen for calls. And it does not have to listen for calls, but it at least needs to be able to make calls. So some examples of views that may not seem like views at first are services and broadcast receivers. A broadcast receiver in particular is an interesting one because you can make a call in a broadcast receiver, but then it's going to die before it hears back. You can't guarantee that it's going to be around to listen for an event from the store. But it's still a view. It still constitutes a view. It can make that action request. So, if you have a broadcast receiver that's waiting for, Bluetooth to turn on, and in order to perform an action, Bluetooth turns on, that broadcast receiver hears that, it can make a call to the actions creator and then be done with it. And then any views that are alive and are listening for the response from the store can still react, right? So that's something that I wanted to mention. Testing with Flux is great, especially if you are using TDD, because of the simple approach and the consistency of the pattern. It makes TDD very easy. Testing your actions creator is just a matter of verifying that that the actions. That the proper action is being created with the right values, and that action is being passed to the store. And that is pretty simple to do. Testing the stores is really where the bulk of your unit tests will happen, and this is what makes the architecture clean, is since we're doing all of our work in the stores and all of our state and our data and our business logic are contained in the stores, we can do all of our unit testing on the stores, and that means everything can be JUnit testable, rather than having to deal with having your Java logic mixed in with your Android components, which tends to be a real problem if you're not using a clean architecture. And then finally, your views can be tested through instrumentation testing, and you just have to verify that the proper action is called when a view is interacted on. So you're just verifying that when you press that button that it calls actions creator.attempt login, for example. And that's all I got. So up next, Nigel is going to present his awesome library, Flux Ion. He will tell you all about it.